All right, folks, let's take a look at number 14 from section 4.5 WebAssign. And I picked this problem because of this right here. We have to anti-differentiate with respect to theta, and I know that some of you are panicked, possibly even in tears, because there's no x in this problem. So theta is a variable just like x is, so we're going to treat it just like we would any other variable. And the first thing we're going to do is look for some u substitution that might help us here. And the inside function here is 7 over theta. So let's take a look at what happens if we let u equal 7 over theta. Know that we can rewrite this as 7 times theta to the negative first power, because that's what 1 over theta is. It's u to theta to the negative first power. When we differentiate that, we're going to get negative 7 times theta to the negative second power d theta. And then I can rewrite that as negative 7 over theta squared d theta. And that's almost exactly what we need. Let's go back and take a look at the original problem and do a little bit of rewriting here and see how this helps us. So I'm going to take a look at the antiderivative cosine of 7 over theta, and then I'm going to move that 7 over theta squared back here, and right there we see we have almost everything we need. So this is cosine of u. This, well, take a look back at our u substitution. If I multiply both sides of this by -1, I get the opposite of du equals 7 over theta squared d theta. And that's exactly what we need. So this quantity right here is the opposite of du. So it's like -1 times du. So what I'm going to do is I'm going to do my u substitution. That negative du, I put the negative sign out front as a constant multiplier of -1. I have cosine of u du. When we anti-differentiate cosine of u, we get sine of u. Notice I still have that negative multiplier out in front. And then we add our constant. We're almost done. All we have to do now is go back to our function in terms of theta. Since u equals 7 over theta, I substitute u equals 7 over theta, and I'm done. Wow, that was a lot easier than it looked.